Good day. Whoa. We are looking at classifying matter, and you're going to see a chart at the beginning and later at the end. So we know chemistry is the study of matter. So that's anything around us that has mass and volume. And the classification of matter is hugely important if you are a chemist, because when you encounter something, a chemical or a sample, if you can figure out what type of matter it is, then you have a better idea of what you can do with it, how you may separate it, these kind of things. So here we have matter. And we either have pure substances or we have mixtures. And I tried to mix up the mixtures here, so hopefully that's impressive. Now there are other kinds of divisions you may run into in future chemistry courses, but for Chem 11 this works pretty well. So pure substances are elements or compounds, and that means they have a fixed chemical formula, a fixed arrangement of atoms of each element. Mixtures don't have a set chemical formula. They're made of more than one material, and these two or more materials do not chemically combine. So we have solutions, we have suspensions, things that happen at school from time to time, and we have mechanical mixtures. Now on the left, elements, compounds, and solutions are homogeneous. And you might say, hey, a solution's homogeneous. Well, when we look at it, you cannot see the separate components. Suspensions, mechanical mixtures, you can see the separate components, so it's heterogeneous. And what we're going to do is we're going to go through these 5 categories of matter. So pure substances, which we know are elements or compounds, can only be altered by chemical changes. So if I have different elements, I may chemically combine them into a compound. Or if I have a compound, I may chemically break it down into its elements. Anything on the periodic table is an element. So it is pure, homogeneous, made of atoms. Each element has its own kind of atom. Well, we know it's a bit of a lie because there's isotopes, but each element is defined by its number of protons. So you might recognize that a silicon, if you're trying to poison someone, there's some fun chlorine. And wouldn't that be nice to have a bit of gold? So anything on the periodic table is an element. It's going to be a pure substance. So that's pretty easy. Compounds are made of molecules if they are covalently bonded. And if they're ionically bonded, the compounds will be made of formula units. So this is carbon tetrachloride. And if you go on in organic chemistry, this is a chemical you'll run into, but we will not talk about it right now. So if we look at this, you might recognize this from grade 8. Cubic crystals has to be salt, so sodium chloride. And you might recognize this from grade 8, bluestone, which we know is copper 2 sulfate. So those are all compounds. They all have a set formula. There's a precise way for the number of atoms of each element to combine. Every time we have 1 carbon atom, we have 4 atoms of chlorine. Every time we have 1 atom of copper, we have 1 atom of sulfur and 4 atoms of oxygen. Now we look at mixtures. And so we know these are 3 mixtures. And they're made of more than one kind of particle. They're made of more than one kind of material. But the nice thing is we can change them by physical changes. And so often they are easier to separate than compounds. So if it's a mixture, automatically it's impure. You got to know solutions quite well last year. You have a solute and a solvent. Sometimes you have more than one solute. And they're so well mixed they appear the same throughout. That's why they're homogeneous. So if you take a sample from near the top or the bottom, Doesn't matter. It's going to have the same composition. We know we form solutions by dissolving. We separate them by distillation. And so if we have a mixture of ethanol and water in our moonshine bottle, we can vary the ratio of ethanol and water. So since it doesn't have a fixed proportion, that's what makes it a mixture. We don't know what that ratio is. And if you remember organic from last year, briefly, you might recall this was the formula for ethanol, but that is something we will hit near the end of the course in more detail this year. Alrighty. Alloys are also a solution. They're a mixture of metals. And so to make the mixture, you have to heat the metals up to high temperatures so they become liquid, and then stir carefully with something that probably not a wooden spoon, it'd probably catch on fire. And in the old days, dental alloys, well, mercury fillings, mercury, tin, and silver would be blended together. And so often I'll have students who threaten to sue me, and I just laugh and I say, well, I'm old enough, I have mercury fillings. So that's what's giving me the brain damage, so your lawsuit will fail. So there I stuck a phone into my mouth to get a nice picture of a mercury filling. You might recognize that character. And there's the Kool-Aid. So Kool-Aid is a solution. Suspensions are similar to solutions, except they're heterogeneous. And suspensions, you generally can see that they're made of more than one material. And at some point, I'll make a little video where I show you samples in 3D, so it makes more sense than just seeing pictures. A suspension does not mix well, and to keep it mixed, you have to keep shaking it or stirring it. So like when you buy paint at a store, often they'll put it on a shaker and they'll shake it for several minutes because they're trying to completely blend that paint together. And before you paint, you got to stir it because it will have settled out over time. And you might have heard of homogeneous milk or homo milk. And milk itself doesn't want to stay, or wants actually to separate out. And so they're always trying to blend these things together. Suspensions typically can be separated by filtration or a centrifuge. So if you had a precipitate that you made, you could run it through a filter. Centrifuge just means you're going to spin it. Your blood is a suspension, so you could put some of your blood into a test tube, attach a string to it, whip it around, and the heavier parts, the assorted blood cells and platelets would settle to the bottom, and the plasma, the yellow layer, liquid, would remain on top. So the denser material will settle out. So there's paint, and there is tomato juice. Some people like that stuff. Ugh. And here's a precipitate you made probably at some point in high school. There's lead 2 iodide. And so it's gone cloudy. You can't see it through it. It's a solution. Solution, when you have a liquid solution, you're going to be able to see through it. It may have a color, but it's going to be transparent. But we have these larger solid particles that block light, and that means suspensions typically are going to be translucent or opaque. Mechanical mixtures, impure, heterogeneous, made of more than one material. And really these are mixtures of solids. And so they'll just sit there. So let's say you have a breakfast of granola and sugar and thumbtacks, but no milk. So just a mixture of solids, they'll just sit there. Not much will happen, and you can pick it out. You might get lucky and be able to pick it apart using a sieve based on different size particles, or you might be able to use a magnet. So we look at concrete. Concrete is an example of mechanical mixture. That is the world's most disgusting picture of a pizza. That is supposed to be a pizza. Looks like it's been run over, but a pizza is a mechanical mixture. And there's our breakfast of thumbtacks and granola. Oh, it says sand thrown in too to polish your teeth. So there's our chart. When we look at matter, typically we actually work from the bottom. If it's homogeneous, we know it's an element, compound, or solution. If it's heterogeneous, suspension or mechanical mixture. So if all we see are solids, we're going to bet on mechanical mixture. If we see A liquid that's cloudy, we're going to bet on a suspension. Often, it's hard to tell compounds and solutions apart because we may have some liquid compounds that look a lot like solutions. So that's one way that we classify matter. The last thing is, these beasts are altered by chemical changes. That's elements and compounds. Solutions, suspensions, mechanical mixtures are altered by physical changes. They're formed by physical changes and they're separated by physical changes. Lots of fun.